Alright, so this video is supposed to be a review for honors chemistry for the chapter 4 exam, part 1. So what I'm going to do is I'm going to go through key points of atomic theory and then highlight them. That way you're prepped for your exam tomorrow. Alright, so here we go. Let's see here. First and foremost, when you think of an atom, if you ask someone to draw an atom, this is how most people draw an atom. They would put the electrons. We know that electrons are located in the electron cloud. Protons or neutrons are located in the nucleus. But back in the day, when you go way back in atomic history or scientific history, Democritus and the Greeks, or Democritus, thought that an atom was just a hard sphere. That was it, because they didn't know there was protons, electrons, and neutrons. So when you think about the first model of an atom, or what we thought an atom was, it was just a hard sphere. Think of like a billiard ball or something like that. Then the model undergoes changes each time we discovered a particle. The model would change. You discover the electron, you add the electron into the model. Then the proton is discovered. Proton and the electron are now in the model. And finally, the model shifts at the very end. You end up with protons, neutrons, and electrons. So the key thing when you're learning about atomic theory is, how did it start? What happened to cause the first change, the second change, and then finally to the model that we look at the end of chapter 3, and that's what I'm going to go over. First and foremost, John Dalton, back in the early 1800s, proposed that it was considered the father of atomic theory. He proposed 4 ideas. First and foremost, an element is composed of tiny particles called atoms. That was kind of a throwback to what Democritus had said. He said that all atoms of a given element are identical. We know that's not true anymore because you guys learned about isotopes, so that's a key thing to remember for the test, that he was wrong about that. The existence, at that point, they didn't know about the existence of isotopes. So that's one area where he was wrong, and that different elements, atoms of different elements are different because of different number of protons. He wasn't sure why, but he knew that we were different. He discovered that atoms combine in whole number ratios. We still know that today. And then finally, chemical reactions are just a rearrangement of atoms. That's it. So they're rearrangement of atoms. He didn't know about the parts of atoms. He thought they were indivisible. He didn't realize there was a proton, a neutron, and then finally an electron. That was the other area of his postulates that was not exactly correct. When you think about it, his first thing he said was, all the atoms of element X are identical. Well, isotopes, we know that they're not exactly identical, but they do have the same number of protons. If you take a different element, it would be different. Now we know because different number of protons. And then compounds always are formed of whole number ratios of atoms. That's a key part. So the first discovery, the first atomic particle that was discovered, and you need to know, these are key things you would need to know to do well on the test. The first one is J.J. Thomson. You need to know he discovered the electron. He used the cathode ray tube. That was the name of the experiment. That was you saw it in class, the beam of light bent towards a positive pole. They figured out that there was a negatively charged particle. So the electron was the first thing that was discovered in the atomic model. So it went from being a sphere, nothing, to a sphere with negative charges and a giant positive charge, because they knew it had to cancel. So key things, J.J. Thomson discovered the electron, cathode ray tube. Millikan was able to determine the mass of an electron compared to the rest of the other atomic particles. It tends to be very, very small. The mass, that's the actual mass of the electron that was discovered in his experiment. Conclusions based on what they discovered with the electron. A couple things are, they knew that elements had to contain identically charged particles. So atoms were neutral, they knew that. So there had to be a positive particle, but they also, to balance out the negative particle that they discovered, they just didn't know what it was using the cathode ray tube. The other thing that came out of it is they knew that electrons had such a little mass that atoms had to have other particles that account for most of the mass. And we get into that when we talk about isotopes and mass numbers, because protons and neutrons, we say, have a mass, and we pretty much say electrons don't have a mass, or it's very negligible. Next, that was discovered after the electron was the gold foil experiment. which was the discovery of the proton. So the proton was discovered. The idea was Ernest Rutherford did a gold foil experiment where positive particles were shot out and passed through gold foil and hit a screen. Some of the particles actually hit the gold foil and deflected and caused the screen to glow in other places. The reason they were deflected, they were supposed to go all the way through, was they were hitting the dense nucleus. So you see the nucleus right there? A dense positive charge would cause, you see a deflection right there, some of the alpha particles to be deflected. So that was key in discovering the nucleus. The nucleus contains a positive particle, that was the proton. The gold foil experiment is how it was done. Rutherford, using alpha particles, firing them, discovered the nucleus. Key parts of his discovery were this. They knew the nucleus of an atom was small. How did they figure that out? Well, since most of the particles went through, they weren't really ever hitting anything. It was very infrequent that they were hitting stuff. So that was the first thing. The nucleus is dense because when it did hit it, it did ricochet back. The other thing he discovered was the nucleus was positively charged. He was able to discover that because the alpha particle was deflected. Like charges repel, opposite charges attract. So these are the key things when we talk about the nuclear model of the atom. What we're talking about is the fact that we have a nucleus. You have positive charges, protons in the nucleus. Then around the outside, you have the electrons. That was the idea when we talk about a nuclear model of an atom. That's what they're referring to. So if you compare the model before, J.J. Thomson discovers the electron. So it was called a plum pudding model, so it only had electrons. So they assumed if they fired positive particles, they would all pass through. The nuclear model came about because some of the particles were hitting something. We now know it's a nucleus with a positive charge, and that's what was causing the deflection. So that's why the gold foil experiment is so key in understanding changes in atomic model. Last particle to be discovered was the neutron. James Chadwick is the guy that discovered it. Neutron, we know the neutron is actually in the nucleus with the proton and the neutron. That was discovered in 1932, and thus you end up with a full atomic model. You have the electrons, which exist outside in the electron cloud with basically no mass. You have the nucleus, which contains protons and neutrons, which makes up the mass of an atom, or what we call the mass number, which we'll get into in the second part. Subatomic particles, there's three of them. I just kind of showed you: electron, proton, and neutron. The electron has a -1 charge, proton has a charge of +1, the neutron has a charge of 0. These are the actual masses in the laboratory, but in chemistry we use relative masses. So when we talk about relative masses, we say the relative mass of an electron is pretty much 0 because it's still pretty small. We're going to say this has a relative mass, or an atomic mass unit of 1, atomic mass unit of 1 there. They are both located in the nucleus. The electrons are located in the electron cloud. Key things that you have to be able to do in the test tomorrow. Here's one thing. You have to be able to find the mass number. You have to be able to find the mass number. Remember, mass number is going to be protons and neutrons. This is where your periodic table is your best friend. The periodic table always lists protons. So that's the first and foremost thing that you should do when you're taking a test on atomic structure, is look at the periodic table and verify the number of protons. That will help you answer a lot of the questions. So like, for example, oxygen. When I look at the periodic table, oxygen's atomic number is 8. That means I have 8 protons. If it's not an ion, it means protons and electrons are the same. So I have 8 and 8. That's when the idea, we remember that the mass number is going to be just the protons plus the neutrons. So in this case, 8 plus 10, the mass number is going to be 18, and we do write the mass number after it. So that's basically how you approach it. If you look at the bottom one here, right here, because the number of protons, it allows me to identify the element. 15 protons, you're going to deal with it's phosphorus. Since I know it's phosphorus, I know 15 protons, 15 electrons. Once I have the mass number, what I'm able to do is subtract. Remember, basically mass number minus the number of protons will always tell me the number of neutrons. So I get 16, the mass number is 31. We always write it on the back of the element's name with a dash. This is the key thing you have to be able to do tomorrow. Hypothetically, here's an example. If I give you magnesium, and it has these values here. This is the atomic number, which is the same as the number of protons. This is protons plus neutrons is the mass number, and over here is the charge. which means basically it's either gained or loss of electrons if it's an ion. So if I look right here, protons, easy enough to identify. How many protons does it have? 12. I can verify that on the periodic table. Neutrons, if I subtract the top from the bottom, think of it like this, 24 minus 12, that's how many neutrons I have. I'm going to have 12. Because if I subtract the top from the bottom, the only thing left is the neutrons. Easy. What about electrons? Here's the way I do it. You take whatever the charge is and you do exactly the opposite to the atomic number. If the charge here is plus 2, what that means is I subtract 2, whatever the opposite is. Opposite of the charge gets me the number of electrons. So in this case right here, I have positive 2. That means I'm going to subtract 2 from the atomic number, which is 12. That means I have a total of 10 electrons for this one. Here, we'll do another example. What if I gave you this symbol right here? Yes, it's an ion because it has a charge right here, -1. First thing, protons, easy enough, 17. Neutrons, subtract these two numbers, 37 minus 17. Number of neutrons is going to be 20. Finally, electrons. I look up here. What is the opposite of a -1? Plus 1. So that means I take 17 plus 1, and I get 18 electrons, because this represents a charge since it's an ion. One of the things they're going to ask you to do on the test is you're going to have to complete this. So if you look right here, I see magnesium. My first thing is I'm going to look at the periodic table and realize its atomic number is 12. So I'm going to put the 12 right there. In this case, they ask you to identify, is it an atom or an ion? Well, if it has a charge up there, it means it's going to be an ion, which means the number of protons and electrons are different. What's the opposite of positive 2? -2. So 12 minus 2, 10 electrons. Then, when I go to find the number of neutrons, I'm given the mass number, because remember it goes protons plus neutrons is equal to mass number. So I plug in what I know. 26. I know I looked on the periodic table, I got my 12, and then I got X. Do a little bit of math, I realize my number of neutrons has to be 14. A bit of algebra, 14 right there. Atomic number is always the same as the number of protons. Boom. The charge is the same thing that's listed there. It has a charge of +2 or 2 plus, whatever. You do the same thing for this. Like if you look right here, rubidium, that's going to be an ion because I see a charge. I'm sorry, chlorine has a charge. Rubidium has no charge, so that was going to make that an atom. So you're looking at chlorine. Look on the periodic table. I see its atomic number on the periodic table is 17, so I drop the 17 right there, 17 right there. Next thing is I need to know the number of electrons. Well, if I look, -1 charge, opposite to the atomic number. So plus 1, 17 is 18. I think I kind of did this one already. The mass number is 35, so I just take 35 is equal to the number of protons or atomic number 17 plus X. Then I can calculate out the fact that it's 18 neutrons. I'm good to go. Charge is -1 based on the value right there. And those are key things you have to be able to do for atomic structure. Part 2, I'll show you how to calculate I'll go over what an isotope is and how to calculate average atomic mass.